Hi, this is Martin and welcome to the next video in my series looking at getting started with OpenInsight 10. This is lesson 3 and we're going to be looking at the OpenInsight native database that ships with the product. Now, if you know about OpenInsight's linear hash, or you've worked with multi-value data, or you're just not interested in learning about the underlying database, feel free to skip this video. This is primarily going to be a PowerPoint presentation, so you can skip this one and go straight to the next lesson, in which we're going to be creating our first dictionary, our first set of tables. But for the moment, let me just give you a little bit of background information. So, OpenInsight's native database is referred to as the linear hash database, and in short, it's very, very good at managing the multi-value data that OpenInsight is based on. Now, multi-value data is delimited data, and we'll have a look at that in a few moments. But it's multi-value data that we support, and that data also supports variable length fields. So these are fields that can be any sort of size. You don't have to predefine them when you are creating the dictionary, and OpenInsight will manage the size. So if you were to define them at 255 characters, for instance, but you needed to go over, OpenInsight will just expand and be able to cope with that amount of data. So it's really useful for when you're putting systems together very quickly and you might not necessarily know how many letters or characters are going to be going into a particular field or column. You can just set up whatever you feel, and OpenInsight can manage the rest. It's also ideal for storing, querying and retrieving large amounts of data, and we found that the database and the OpenInsight based systems have grown over the years as businesses have pushed in more and more data to millions and millions of rows. We get reports where people have done tests and their systems will scale with no measurable degradation in performance. And we've also had people that have extended their systems to the web, where the linear hash database is ideal because it is pretty lightweight, and we're not managing lots of different joins and loads of different tables. We can query the data and get back the value very often in one or two disk reads, which is great for optimizing web-based solutions. So, we're pretty well set where that is concerned. Just to touch very quickly on the non-native supported databases that we have in OpenInsight, we have what we refer to as a data connectivity technology. So these are data connectivity things. I won't go into too much detail about how they work, but it's a technology that is consistent for non-revelation databases. And there's three categories that we support. The first is multi-value databases, and we currently support Universe and Unidata, which is collectively known as U2, D3 and QM. And we have also had OpenInsight running against Univision, and although that's not an officially supported third-party database, I've just thrown that in there in brackets. We're also now looking at supporting cloud-based databases, and from OpenInsight 10, the first release, we're supporting Couchbase, and there are plans for MongoDB and probably a few others. And within the SQL world, the SQL data connector will handle multiple flavors of SQL. So we're pretty much set with our own database and third parties and different licensing for each of those. I just want to touch on some terminology. Now, whilst we're going through the videos, I tend to alternate between the two, which I know is really bad. The reason for that is I've had no formal training. I've taught myself a lot, and some of that has been through documentation at OpenInsight that Revelation have created for OpenInsight, so I get the OpenInsight terms, but I've also read a number of books for SQL and Java and other things, and they use different terminology. So this table just touches on a few of the things that you might want to be aware of. Mainly, when I refer to a table, that can be a file as well. A row refers to a record, a column refers to a field. So just bear those differences in terminology in mind whilst we're actually going through these videos. So the native table format, when you create a dictionary, there are three types of files that are created. So the entity types are data files, data dictionaries, and data indexes. Now you might not necessarily have indexes for all of your tables, but for the purpose of this presentation, I'm going to assume there are all three. There's a specific naming format, so when you're looking for things within the repository, then you can find them. So data files would be just simply what you decide to call the table, so my_data. The dictionary that is created, now the dictionary is basically an overview of what the data is, so it details all the columns and their attributes for the columns. And that file is held within OpenInsight as dict.my_data or dict. Whatever your table name is. And then we have data indexes. So if you create an index, OpenInsight will create what we call a bang file, which is exclamation mark, or if you're in the States, bang. So an exclamation mark, and then the name of your table, your dictionary. If you were to create all three of those at the same time, one after the other, the actual file names that OpenInsight will create will be in the format of rev, and then a number, normally a 5-digit number, and then .lk and .ov. LK is the main file, and then OV is an overflow file. And then we start talking about buckets and how the data fills one bucket and then it overflows into another one. So if you were to create your table and then your dictionary and your index one after the other, then the numbers would be sequential. Obviously, if you were to create the data file and then the dictionary at the same time, they would be sequential. If you were to create an index later on after you've created some more tables, then the bang file would have a larger number that wouldn't necessarily be in sequence. But it doesn't really matter about the file names, because within OpenInsight we can refer to them as the naming format option. Indexes are important within a system, and there are a number of indexes that we can create. There's bitmap indexes, there's relational indexes, there's B-tree indexes, and I'm not going to go into any detail on any of these because a lot of it goes over my head. But the key thing here is, if you've got an index on the system, you can either go straight to the ID to get the information. If you haven't got the ID, then you can go straight to a value. So if we were to look for Phillips, then OpenInsight can very quickly grab all of the patient numbers for Phillips to give you an option, and then you can pick the one that you want. So rather than trawling through the whole of the table now, we can just go straight to the Phillipses, grab that group, get the patient numbers, and return the data very quickly and easily. And bitmap indexes in particular are blindingly quick, where you've got things like yes and no, Mr. and Mrs., you know, that type of thing. So very, very small amounts of data. B-tree indexes are very often used for larger amounts, but if you want to know more about indexing, then that would be one for proper training. MultiValue data. Okay, the columns of data within an OpenInsight system are basically delimited, so it's held in the database, as you can see in the first bullet there. So unit 1 with a value mark, I think that's the right terminology, and then boundary house another value mark, and it goes through accordingly. So it's stored in the database in this string, and each of these values have got position marks. So if I wanted to do a search and get all of the addresses in London, then I can say do a search on position number position 4, and it will go to position 4, find all the Londons and return those back. So again, this is another example of how efficient OpenInsight can be. Now, when it's viewed on the screen, normally in an edit table, you wouldn't want to see the value marks. So OpenInsight will automatically put the first value in row 1, and then it will get to the value mark, and then it will put the next value into row 2 so that the address is produced correctly on the screen. And that's the same with reports as well. This obviously enables the data to be retrieved in a very fast and efficient manner. As I've just said, if you want to just put all the Londons in, then you can just refer to the position within the string. It also makes entering data very easy, because if you've got multiple lines of an address, and very often you just get address 1, address 2, address 3, address 4 maybe. But if you've got address line number 5, 6, and 7, then it makes it very difficult to put that in. What do? Do you combine unit 1 with boundary house? Do you combine boundary house with Boston Road? It gets a little bit mixed up. So in practice, what you would do is you would probably have unit 1, boundary house, Boston Road, all under address, and then you might have town and postcode split out, but you don't need to. It's entirely up to you. And one of the other things that this does is it reduces the number of data relationships that you've got in your system, this multi-value data idea. So when you're designing your database, you need to start thinking about third normal form. You will very often design your data structures to third normal form, but then make a decision, is there any value to splitting this out into separate tables? If there isn't, then just create a multi-value column within your database and forget about the multiple tables. And this means that we've got far fewer tables to maintain within our database, and far fewer inner and outer joins, and far fewer lookups and things that I really don't understand. So I'm not going to get into any real detail. But what I'm told is when you are retrieving a record, very often it can be 1 or 2 disk reads against 1 or 2 tables, rather than a dozen disk reads against a dozen tables, and you don't have to manage all of those relationships in the tables. So it really is a very optimized and data retrieval system, which is very easy to manage, which is good for me because I'm quite don't know about all these things, and I just want OpenInsight to take care of things for me. Now, MultiValue has been around for quite some time, and it's more recently been referred to as a multi-dimensional database. But more importantly, it's also referred to as a post-relational database, because some of the attributes of the linear hash multi-value database structure suit modern applications much better than some of the relational databases do. Some of the structure within those databases we want to break down, particularly for web and mobile applications. And we're well suited to that. And we're also listed on a number of NoSQL databases. So we get referred to as a multi-value database, a multi-dimensional database, a post-relational database, and a NoSQL database. Essentially, it's all just multi-value as far as Revelation is concerned. Okay, variable length fields. This basically means that your data columns don't have to have a fixed length. When you define them, you can set them to, let's say varchar 255, which would, in the relational world, would normally limit you to 255 characters. Within the OpenInsight world, that column can grow to take more characters, and it can shrink to take less if you want. And it does that through system delimiters. I've got a table on here which shows you the record row. So the delimiter for that in ANSI world is 255, and then in Basic Plus notation, so when we're actually coding this in Basic Plus, it would be an @rm. So a field or column delimiter is 254, and that's an @fm, and a value 253 and @vm. And then the table at the bottom shows how that is how that's used within the OpenInsight world. So you've got, row 1 would be Phillips, and then @fm, which is your field mark, and then Martin with a field mark, and then where you get your multi-value, so those would be single value columns, and then you've got your multi-value column, which is boundary house, Boston Road, London, and that's all split up with value marks, and then the field mark at the end, which tells OpenInsight that we're finished with the multi-value, so now go back to the next multi-value or the next single value, and the postcode is a single value. Now, I haven't explained all of that very well because it's quite technical and it does go over my head a little bit, but there are a few white papers that I wrote quite some time ago when I was trying to learn about this. I mean, probably 6-7 years ago. They need to be rewritten, so they're not necessarily readily available at the present time. But if you do want to learn a little bit more about the benefits of a multi-value database management system, OpenInsight, or why you should be looking at a revelation-based application if you're not already, or achieving more business benefits through multi-value and Revelations OpenInsight, give me a shout. I'll dig these white papers out and email them over to you. But just bear in mind that they are very old. They've got some screenshots of some OI9 screens, and they really do need to be rewritten. Anyway, that's a very brief overview of the underlying linear hash database that is supplied with OpenInsight out of the box. The next lesson, we'll actually look at the tools for creating our dictionary and for housing our data. Thank you very much for your time today. I'll catch you in the next video. Thanks very much. Bye-bye.